In this video, we're going to prove that two lines are parallel using some theorems. To get us started though, we've got some review vocabulary. The first of which is congruent angles. Two angles are congruent if they have the same measure, meaning they open the same amount. Supplementary angles. Two angles that add up to 180 degrees or make a half circle are supplementary. We also need to review what a converse is. The converse of a conditional statement is when you change the if and then in the statement and then rewrite the statement. For example, the alternate interior angle theorem states that if two lines cut by a transversal are parallel, then alternate interior angles are congruent. To write the converse of that statement, we would flip the if and then portions to give us if alternate interior angles are congruent, then the two lines cut by a transversal are parallel. So notice the difference. The original theorem states that anytime you have two lines cut by a transversal and those two lines are parallel, so you start off with parallel lines, then that means that alternate interior angles are always congruent. The converse states that anytime you have alternate interior angles being congruent, then the lines cut by the transversal are parallel. So the original statement starts with parallel lines, ends up with congruent angles, and the converse starts off with congruent angles and ends up with parallel lines. So real quick, again, we use the original theorem to show two angles are congruent. We use the converses, this is really important, to show that two lines are parallel. Let's go ahead and take a look at the converses. The converse of the alternate interior angle theorem we just got through looking at. If alternate interior angles are congruent, then L and M are parallel. The converse of the alternate exterior angle says if alternate exterior angles are congruent, then L and M are parallel. So likewise, we could do the same thing with same side interior or same side exterior. Remember, same side interior or same side exterior meant that angles were supplementary. So the converse is going to say if the angles are supplementary, then the lines are parallel. So last bit, corresponding angles. Remember, corresponding angles were congruent if the lines were parallel. This one says if the corresponding angles are congruent, then the lines will be parallel. Okay, note that none of the theorems mention vertical angles or linear pairs. So just showing vertical angles are congruent or linear pairs are supplementary is not enough to prove that two lines are parallel. For example, take a look at the angles to the right. You'll notice that the angles, the vertical angles, are congruent, but clearly these two lines are not parallel. They're definitely going to intersect each other. That's because the vertical angles only depend on one of the intersections. They don't depend on both intersections. So you can't predict what's going to happen with both lines based on just vertical angles. The same holds true for linear pairs. If you have 75 and 105 making a linear pair, that has nothing to do with both of those lines. It has to do with just that one intersection right here. So again, vertical angles and linear pairs do not prove two lines are parallel. All right, let's go ahead and use what we've learned. Can you prove the two lines are parallel? If yes, by what theorem? And we look at the picture. First thing you want to do is to look at the two angles and try to identify what kind of angles those are. You'll notice that those two angles are alternate exterior angles, and you'll note that alternate exterior angles should be congruent. So when we look at it, we notice that the alternate exterior angles are congruent. So by the converse of the alternate exterior angles theorem, I'm going to abbreviate that by theorem, we know that the two lines have to be parallel. Again, we use converses to prove lines are parallel? Alright, can you prove these two lines are parallel, and if yes, by what theorem? First thing, try to identify what kind of angles those are. You'll notice those two angles are what? Hopefully you said corresponding angles, and corresponding angles should be congruent. In this case, our corresponding angles are congruent. So that means that the lines are indeed parallel. Yes, we can prove they're parallel, and we can prove it by the converse of the corresponding angle theorem. Alright, can we prove these two lines are parallel? And if yes, by what theorem? Alright, so you notice 120 and 60 are same side exterior angles. So remember, same side exterior angles should be supplementary. If the lines are parallel. So we notice 120 plus 60 does indeed equal 180 degrees. So since the same side exterior angles are supplementary, yes, we know the lines are parallel, and by the converse of the same side exterior angles theorem, we know that the two lines are parallel. And we can use these theorems over and over again in a variety of situations to prove two lines are parallel. Let's take a look at just one more example, and then I've got one that will show you that doesn't always work. So let's start off with this one. Go ahead and pause the video, try it out, and press play when you're ready to see the answer. 110 and 70. 110 and 70, you'll notice those two angles are same side interior angles. And if you'll remember, same side interior angles should be supplementary. In this case, they are. 110 plus 70 is equal to 180 degrees. So they are supplementary, and that means that yes, the two lines are parallel by the converse of the same side interior angles theorem. Sometimes you cannot find a theorem that works. Go ahead and pause the video, try this one out, and press play when you're ready to see the answer. Alright, looking at 95 and 95, you'll notice those two angles are not alternate interior because they're not both interior angles. They're not alternate exterior because they're not both exterior angles. They are not same side interior or same side exterior, and they aren't corresponding. So none of our angle relationships apply to the 95 and 95. So can we prove the two lines are parallel with just the information we're given? Not as of yet. Now, you could make it a little bit more tricky by finding the angle beside it. You remember linear pairs are supplementary, so 95 plus 85 would be 180 degrees. But in this case, 85 and 95 should be congruent. You notice they are not congruent. So again, no, you cannot prove the two lines are congruent. Or excuse me, prove the two lines are parallel. Alright, so in summary, if the following types of angles are congruent, then two lines cut by a transversal are parallel. So if alternate interior angles, alternate exterior angles, or corresponding angles are congruent, then the lines are parallel. Similarly, if you know consecutive interior or consecutive exterior angles are congruent, supplementary, then you know that the lines cut by the transversal are parallel. One way to keep that in mind is that the only ones that are supplementary, the only angle relationships that are supplementary, are consecutive interior and consecutive exterior angles.